Hey everybody, in this video we're going to go through a few more examples for arithmetic sequences. Let's get to it. From the previous videos we know that there was a general formula for any arithmetic sequence, and that was u of n is equal to u of 1 plus n minus 1 times d. Now in this case what we're trying to do is we're given find k given that 3k minus 1, k, and k minus 5 are consecutive terms in an arithmetic sequence. So what that means is that we have u of 1 is equal to 3k minus 1, u of 2 is equal to k, and u of 3 is equal to k minus 5. Now in actuality, these may not be the first three terms in the sequence. All we know is that they are consecutive terms. So this could be 5, 6, 7. This could be 10, 11, 12. But what we're going to do is we're just going to try to find some value that will make this true for these three things being right next to each other in a sequence somewhere. So that's kind of what we're going to do. Is that u of n plus 1 minus u of n is equal to our common difference. Or quite simply, this thing minus this thing equals our common difference. This thing minus this thing equals our common difference. So we could also find that. So maybe we start there and see what we come up with. So if I know that k minus 3k minus 1, and I'm going to put a parentheses around there because I don't want to drop any negative signs, that's going to equal a common difference. And I also know that k minus 5 minus k. So this first one here, this is going from here to here, right? K minus 3k minus 1. This is going from here to here. So that's this one here. So that's also going to equal a common difference. Now we know from algebra that if we've got two things that are equal to the same thing, then these two things have to be equal to each other, right? Yeah, so let's just do that. I don't need to get into it. If you're not familiar with this idea, then you're going to want to go back and check out our video on substitution and elimination. So this thing equals d, this thing equals d, therefore these two things equal each other. Okay, so great. K minus, now if I distribute this negative in here, that's going to mean 3 minus 3k plus 1 is equal to all of this, k minus 5 minus k. K minus 5 minus k. So now I'm going to just simplify all of my like terms.
So I got minus 2k plus 1. I got over here, oops, that's just minus 5 because these two k's are going to knock each other out there. So let's see, I'm going to subtract 1 from both sides. So negative 2k is equal to negative 6. So that means k has got to equal positive 3.
Did I do that right? Yes. K has got to equal positive 3. So let's see if this works. So if I've got, we know it's got to be a common difference. So if u of 2, here we go, u of 2 is equal to 3, then u of 1 is going to be 3 times 3 minus 1, which is 8. And u of 3 is going to be 3 minus 5, which is equal to negative 3. Okay, so let's check. Do we have the proper common difference? Is there a common difference? So if I go here to here, I'm subtracting 5. If I'm going from here to here, 3, did I do that right? No, here's my mistake. This is minus 2. Minus 2. So 3 minus 5 is minus 2. So here we go, minus 5. So we have our common difference. If we needed it, we could say our common difference is equal to negative 5. But we can see here also that we subtract 5 to get to 3. We subtract another 5, we get to negative 2. So this is indeed an arithmetic sequence. Fantastic. Let's look at one even a little bit more challenging than this. Let's see what we got here. Find the general term u of n for the arithmetic sequence with u of 13, or u of 3 equaling 13 and u of 10 equaling negative 5. Okay, so there's a couple different ways that you can do this. Now, I've seen students in my classes do this 2 different ways. I like a more systematic approach, but depending on your flexibility, you might be able to do this one method for some and another method for another, and kind of pick and choose. That's going to be based on your own comfort level with what we're going through. But what this is saying is that we've got our first term, second term, third term, fourth, fifth, sixth, seventh, eighth, ninth, 10th. Whoops, and that's going to be negative 15. So we know that we've got to drop down. There's going to be some common difference that's going to make this thing go from 13 to negative 15. We don't know what that is. But what I do know is that when n equals 3, u of n equals 13. And I also know that, here I'm going to just change colors just to keep it consistent. Let's make this our pink color. I also know that when n equals 10, u of n equals negative 15. So what I see here is if I'm looking at my u of n formula, n minus 1 times d, I have a system of equations. Now, how do I know that I've got a system of equations? Here I've got one unknown value, 2, 3, 4 things that I could drop into this equation at any given time. Here I've got n and u of n. So I've got this thing here. I've got u of n is 13, and I know that n is 3. Let me fix these. This should say u of 3. This should say u of 10. Okay, so I also know that when u of 10 is equal to negative 15, that would be our u of n piece, and our n is going to be 10. So right there. So in both of these, what I have unknown is u of 1 and d. So that's 2 things that I don't know, 2 equations that talk about the same thing. That's a system of equations. Usually we do this with straight lines, but we can do it with a sequence as well, because they're both talking about the same pattern. They're both talking about this same pattern. So here's where I start. I start by saying, all right, 13 is equal to u of 1 plus 3 minus 1 times d. And that simplifies to u of 1 plus 2d. Over here, when I look at the red one, I've got negative 15 equals u of 1 plus 10 minus 1 times d. Or negative 15 is equal to u of 1 plus 9d. Now for me, this is a pretty straightforward system of equations. Here's my 2 unknowns right there, and my 2 equations that are representing the same thing. So I could do elimination, I could do substitution. Now, since this one doesn't have a variable attached to it, or a constant attached to it, what I think I'm going to do is I'm going to get u of 1 isolated, and I'm going to create a system of equations of substitution just like I did up here, right? If I've got both sides equaling to u of 1, I can do the same exact thing as I did in the previous example. So I'm going to take 13 minus 2d is equal to u of 1. And then I'm going to take negative 15 minus 9d, and that's also equal to u of 1. So therefore, this 13 minus 2d is equal to this. 13 minus 2d is equal to negative 15 minus 9d. All right, so let's isolate. Let's find d.
So if I add 15 to both sides, I'm going to get, what am I going to get? Add 15 to both sides, I'm going to get 28 minus 2d is equal to negative 9d. I'm going to add 2d to both sides, so that's going to give me 7d, sorry, minus negative 7d, divide both sides by negative 7, so d equals negative 4. Okay.
So in this case, I could also find out what my u of 1 is, because I'm trying to find my u of n. So u of n is finding this general formula, this thing with all of our values for this sequence dropped inside there. So I just need to find now what u of n is, or u of 1 is, so I could go backwards 2 times. So if if going from left to right, if here the D says subtract 4 and this says subtract 4, then that means if I'm going back this way, I have to add 4. So this would be 17 and this would be 21. I'm adding 4 to go back the other way. Right? And that makes sense because 21 minus 4 is 17, 17 minus 4 is 13, subtract, 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 subtract. So now I've got enough for my general formula where u of n is going to be equal to 21 plus negative 4 minus 1. Nope, sorry, I did that wrong. It's going to be n minus 1 times negative 4.
So my u of n is equal to 21 minus 4n
plus 4, or u of n is equal to 25 minus 4n. And there's my general formula for this sequence. Now what some people will do is they'll say, look, if I'm going this way all the way down here, if I take, kind of using the same idea, if I take this thing minus this thing, I would get my common difference. But it's not just this thing, it's not just negative 15 minus 13 to get a common difference. That's going to account for 1, 2, 3, 4, 5, 6, 7 common differences in there. So what some students of mine do is negative 15 minus 13 is equal to negative 28. So this jump from here all the way back to here, we have to take 28 units, 28 values, the difference of those two values is 28. And as we just said, there's 7 steps in there. 1, 2, 3, 4, 5, 6, 7. So to get from negative 15 to negative 13, I have to do 7 jumps. So that negative 28 has to be divided into 7 jumps, which gives me a value of negative 4, and that's our common difference. And then at that point, you could do all the rest of it. The thing with this is, the thing with this last step is, it definitely uses some reasoning. If you're just trying to answer a question on an exam, it works fine. But what I like about using the system of equations is I feel like that's going to be a little bit more systematic. There's a little bit less room for error in counting or anything like that. And I know it seems fairly straightforward, but it's a little bit more structured. It's got a little bit more of a process to it than doing this. Now, if you fully understand this, like how am I jumping all the way back? I'm jumping 7 steps back to get from here to here. Cool. That's awesome. We're kind of always in this conflict. What does the math teacher want you to know? What do you need to know? Now, I would guess a question like this might be worth 6 points on an IB exam. Now, what would happen is if you did this, you would probably get all of the points because there would be some method of trying to find the common difference. There might be something of trying to use the general U of n term formula, working backwards to find U of 1. So you might be able to get there. But I know mathematically this is clean, this is organized, and this might be a better way to make sure that you get all 6 of those points. So, again, a little bit of what does the teacher say, what do your fellow students say, you kind of need to pick and choose. There's my teacher advice to you for this, and I hope this video was helpful, seeing some slightly more advanced examples, and I will talk to you in the next video.